Hi everyone. So today for your higher lesson we are going to look at lesson 1, which is bonding in the first 20 elements. We are going to do lesson 1 and lesson 2 today because they are quite short and we should be able to get through both of them. So what do we want to achieve today? We want to investigate the bonding and structure in the first 20 elements of the periodic table. So you're going to learn some new elements or the bonding and structure of some new elements that we haven't discussed before. And success criteria is for any element within the first 20, you can state the bonding and structure of that element. So metals first of all, and I will instruct you to go to page 2 of your notes. You have a chunk of the periodic table there, and you're going to want to, if you have some coloured pens and pencils, that'd be good. I want you to colour in the sections that I'm talking about. So first of all metals, they are on the left of the staircase line, as you know, have a metallic lattice structure where the positive ions are attracted to negative delocalised electrons. So we had a wee talk about this in the last video. Hopefully everybody is up to speed with metallic bonding. So everything to the left of the staircase line, you have a little key on page 2 of your notes. I want you to colour in all the metals one colour. Second group are the noble gases, so those are group 8 or group 0, right at the very right hand side of the periodic table. They are monatomic gases. Now we've had a look at diatomic elements before. Monatomic just means one atom. So they do not bond to form compounds, they don't interact with other species to form molecules. All they do is they go around by themselves as monatomic gases. So I've put in some at the bottom here for you to see: helium, neon, argon, krypton, xenon and radon. So group 8 can be coloured in a different colour to represent the monatomic gases. Next we have some covalent networks. 3 elements that you have to remember are covalent networks are carbon, boron and silicon. Now I've put in 2 examples of the carbon covalent networks, which are diamond and graphite. Remember, graphite conducts electricity because it has delocalised electrons in the rings. Diamond does not, nor do any other covalent networks conduct electricity. Graphite is the only exception. So carbon, boron and silicon can be coloured in a different colour in your key on your periodic table. Next we have discrete covalent molecules. So you have covalent molecules which are gases, and the diatomic elements, most of these are gases. So we've got hydrogen, nitrogen, oxygen, fluorine and chlorine. Now you'll notice bromine is not in that list, and that is because bromine is not in the first 20 elements, so we don't need to worry about bromine or iodine, which we know bromine is a liquid at room temperature and iodine is a solid. When we're talking about the first 20 elements, all of the diatomic elements or the discrete covalent molecules are gases. They have strong covalent bonds in the inside, so between the atoms you have a strong covalent bond, but between the molecules we have weak intermolecular forces which hold them together. We should know that from National 5. So discrete covalent molecules or covalent molecule gases are to be coloured in a completely different colour in your key and on your periodic table. There are some covalent molecular solids, being carbon as a fullerene. So these are on page 2 of your notes as well. You have C60 fullerenes. Now these are made up of 5 and 6 carbon rings. And this is where carbon exists as a covalent molecule, so a covalent molecular solid. The other 2 examples, and these are the 2 that you want to be able to draw, are phosphorus, which is a P4 molecule, so there's 4 phosphorus atoms in the molecule, and sulfur is S8. Now you are going to have to be able to draw these structures. Phosphorus is quite simple. You just draw a kind of triangle at the bottom with your bonds pointing up to the last one at the top. Sulfur, what I like to do is I like to draw a big W and a small w above, and then just join up the edges, and that gives you a puckered ring shape, it's called. It kind of looks like but the Batman symbol, or some would argue the Wonder Woman symbol. You can draw it however you like, as long as it looks like that and it has 8 sulfur atoms in the molecule. So those are your covalent molecular solids, and those should be coloured in a different colour as well. Now, I know that carbon will already have been coloured in your covalent network colour. That's absolutely fine to leave it as it is, but just a wee exception, just remember that carbon can also exist as a covalent molecule in the form of a fullerene as well. So a little summary of what we've done so far. This is what your periodic table should look like. So have a different colour for covalent molecular gases. You should have your metallic lattice, so that's the orange ones, your monatomic group 8s, and your covalent networks. The only one missing from here is your covalent molecular solids, which are P and S, so they should be a different colour, just to represent that those are the solids, whereas the other covalent molecules are all gases. So that is a very quick run through of everything you need to know for the first 20 elements. It's very, very straightforward, and most of it is actually revision from National 5, so it's not too tricky. So for any element within the first 20, you can state the bonding and structure. If you have a coloured in with a key periodic table on page 2 of your notes, or you should have by now. Don't worry if you don't have lots of different coloured pens or pencils. You could do kind of light stripes or something. Be as creative as you like. And you also have the important structures at the bottom, which are carbon in the form of graphite, fullerenes, a phosphorus molecule, and a sulfur molecule as well. So P4 for phosphorus and S8 for sulfur. So I've got 3 past paper questions I'd like you to have a wee go at and see if you come up with the right answers. If you can do that, then you have achieved your success criteria for this lesson. So, first one. Which of the following elements exist as discrete molecules? So, I want you to pause the video, have a wee look at the 4 elements there, and then unpause in a wee second, and we'll go through the answer. So which one exists as a discrete molecule? Pause the video. Okay, so we've got boron, carbon in the form of diamond, silicon and sulfur. Now straight away, we should be able to recognise that 3 of these 4 are covalent networks. If something is a network, it's not going to exist as a molecule. So A, B and C are straight off the bat covalent networks, can't be your answer, so it must be sulfur. Now we know that sulfur is one of the solid covalent molecular structures, so that would also help us with this answer. So the correct answer is D, sulfur. That is the only element here which exists as a discrete molecule. Past paper question 2. Which of the following structures is never found in compounds? So again, have a wee look at your answers, pause the video and unpause when you've got your answer and check that it's correct. So which of the following structures is never found in compounds? So we have ionic, monatomic, covalent network and covalent molecular. Now straight away when you read that question, never found in compounds, the noble gases should be pinging up in your mind. These are the only group of elements in the periodic table which do not bond with anything. They have no need to bond with anything because they are all perfectly stable. They have 8 outer electrons, or 2 if you're helium, in their outer shell. They are full, stable, happy. They have no need for anything else in their lives. So the answer then, which structure is never found in compounds, is going to be monatomic. So they're single atoms, they exist as single atoms, they do not want to really interfere with anything. Ionic bonds, you'll remember, are found in ionic compounds, ionic lattices. Covalent networks are a network of covalent bonds, and covalent molecules are also made up of covalent bonds and intermolecular forces. So these are A, C, and D are all compounds. Okay, and a long answer question now. The elements lithium to neon make up the second period of the periodic table, so they've very kindly drawn that out for you. Name an element from the second period that exists as a covalent network. So again, you should be in your mind saying boron, carbon, silicon, those are your three. So you can name either carbon or boron, which are present in this. I've gone for carbon, but you can go for boron if you like. B, why do the atoms decrease in size from lithium to neon? So this is kind of back to trends. Now, you'll find that a lot of the bonding and properties past papers coexist with the trends in the periodic table. They are all kind of asking you the same questions about how the elements act or exist. So you do find a lot of them together. So why do the atoms decrease in size from lithium to neon? If you had something like this, so as I said, it's trends, as you go across a period, the number of protons increases, which means you have an increased nuclear charge. This pulls the electrons closer to the nucleus and the covalent radius decreases. In other words, atoms get smaller. The key thing that you have to have for that mark is you need to say increase in number of protons, which increases the nuclear charge. That's the key kind of part. I would also put at the end that pulls the electrons closer to the nucleus and the covalent radius decreases. Just to maximise my marks, I would always put that in at the end. So, if you have made it through the past paper questions, you understand how to answer these and you've answered them correctly, then well done. You have learned about bonding and structure in the first 20 elements. In the next video, kind of part 2 of this lesson, we are going to have a look at the polarity of bonds, which is something completely new. So make sure that you understand this first wee part as a little introduction before we move on to the next video. Well done.